Hi students, welcome back. Okay, in this video, so would like to explain a question from the chapter vector. And this is your textbook questions, page 2 to 6, question number 5. Textbook form 4, 2020. Okay, 2020. Textbook questions, page 2 to 6. Okay, guys, let us move on to the question. Okay, guys, this is the question. The diagram on your below, right? The diagram on the below actually is a below. I already transferred the diagram from right to the below. Okay, the diagram below shows the sketch of a river. The width of the river is 40 meter and the velocity of the downstream river flow is 1.8. Okay, some textbooks or some reference books, they will use as a water current. So it's actually the same thing. Okay, the downstream river flow is 1.8 meter per second. Hamid wanted to row his boat from P across the river at R, but the boat was swept by the current flow and stopped at Q in 12 seconds. Calculate the speed of the Hamid boat. Okay, now first thing is you should understand a few things first before you want to start move on to the question. Okay, what is the story behind this what do you call this question? Actually, the main agenda of this question is velocity. They talk about resultant velocity, resultant vector. Okay, resultant vector. That means, okay, if you look at this question, guys, if you look at this question, okay, can you see a triangle over here? This is your triangle. I can mark the triangle like this. Can you see a triangle here? Wait, this is your triangle. This one, and this one. Can you see a triangle here? Okay, this is your triangle. Actually, why we are talking about triangle? Actually, triangle is very easy, right angle triangle, especially right angle triangle. Why is right angle triangle is very unique? Because we can apply a lot of things using a right angle triangle. We can use Pythagoras theorem, you can use trigonometry, right? All this we can use. Okay, so that's why I ask you to focus on the triangle there. Okay, can I take out the triangle for you, class? Wait, let me draw for you the triangle. Okay, this one. So I'm going to take out this triangle for you. Okay, so going to take out this triangle for you. Okay, let me draw for you the triangle out here. Easy for you to understand. Okay, so this is the triangle, the same triangle, but I take out from the diagram there. Okay, this is the R, and this is the Q, and this is the P. Okay, so what we have is, class, listen, I label for you one by one. This is your water current. That is, I put a V, W. I hope that you can understand. W stand for the water. So I put a W, okay? So W is 1.8, right? 1.8. Okay, got it? Velocity of the water current is 1.8. Okay, this one is the velocity of the boat that I can put as a VB. Right? This is the VB. Okay, wait, I move this diagram. Okay. So this is your VB. Understand? VB means the velocity of your boat. Okay, this one is your resultant vector. Resultant vector. This is your resultant vector. Okay, I need the velocity of your resultant vector. Okay, the good news here is we already have the resultant velocity. We can find, not we have, we can find. Okay, what is the resultant? Okay, what is the velocity of the PQ? This is the PQ. So PQ is actually the resultant vector, and we also can find the velocity of the PQ. Okay, what is the velocity? Velocity is what? Displacement divided by the time, right? Displacement is actually displacement is a unit vector. Another one is a scalar vector, is the distance, right? The distance. Okay. Okay. So now I'm going to find this distance of PQ. Okay, the distance of PQ. Okay, class, you can find the distance of PQ using the Pythagoras theorem, because this is a 40 and this is 70. Right. So my PQ first. Okay, I'm going to put this one. Square root, right? Square root. What square root? 40 square plus 70 square, right? So what is the value? So let me get from my calculator. 40 square plus 70 square. So can I put as a decimals here? Easy for you, right? This 80.62. Okay, got it? Understand, huh? Okay, and this one is the, we can say as a distance or a displacement, up to you. Okay, so now I'm going to get the velocity of the PQ. So velocity, yeah, velocity of PQ or whatever, or resultant vector. So what is a velocity? Is the displacement. This is the displacement, or we can call it as a distance. Take the distance divided by the time given, time taken, time taken. Okay, from P to Q, it take about 12 seconds. Can you see this one? 12 seconds. From the P to Q is take 12 seconds. So that means I'm going to take a 80.62. So going to divide by 12. So divide by 12. So what I'm going to get here is 80.62 divided by 12. I'm going to get 6.72. So meter per second. Got it? Okay, actually what is this? This is a velocity of your resultant vector over here. This one. Got it? Huh? So this is 6.72. Okay, so we're back to this triangle. Now the question asks, look at the question. Calculate the speed of the Hamid boat. This is the velocity, the speed or the velocity of the Hamid boat. Understand? So you need to find the VB. Okay, guys, this one is actually a right angle triangle, right? So we still can go back to the Pythagorean theorems to get the VB, the velocity of the boat. The velocity of the boat is still the same process. I'm going to get Pythagorean theorem. That is 6.72, right? Square minus 1.8 square. So what is your VB? So square root 6.72 square minus 1.8 square. So your final answer going to be 6.47. 6.47 meter per second. Okay, so this is your final answer of your question. So the velocity of the boat. Understand? So hope that you can understand this one. Actually, very simple question, guys. Very simple question. So this is your entire solution. Okay, so you can see yourself. Actually, it's just a resultant vector idea. Okay, so hope that you enjoyed the video. Thank you, guys. Have a nice day. Bye-bye.